All right, let's do a lesson here on combining random variables. How do we calculate the average value and standard deviation of combinations of different random variables? The expected or average value of the sum or difference of two random variables. X is one random variable, Y is another. I want to find the average value of either the sum or difference combination of those two random variables. Take the expected value of the first random variable, X, add or subtract it with the expected value of the second random variable, Y. If I'm doing the sum of two random variables, I take the sum of their two expected values and add them together. If I want to find the average value of the difference in two random variables, obviously just subtract the two expected values together. Now the variance and standard deviation is given with the next two formulas. When combining random variables, it's the variances that combine, not the standard deviations. The variance of the combination of two random variables, X and Y, reads as this. The variance of X plus or minus Y is the variance of the first random variable, X, plus the variance of the second random variable, Y. By combining two random variables, I'm adding more variability. I'm increasing the total amounts of variance. No matter if it's adding or subtracting, I add the two variances of the two random variables together because I'm increasing the amount of variability by introducing another random variable. The variance of a multiple of a random variable, the variance of a constant times X, is that constant squared times the variance of X. Because variance is squared units, variance is the square of standard deviation. When I want to find the variance of a multiple of a random variable, some constant a times that random variable X, I take a squared, because variance is in square units, times the variance of X. All right. So let's practice that with these values that I have on the board. X and Y are two random variables with the given distributions. I have the expected value and standard deviation of X given as 80 and 12. Expected value of X is 80 and the standard deviation in X is 12. The average or expected value of Y is 12 also, and its standard deviation, the standard deviation of random variable Y, is 3. I want to find the average and standard deviation of different combinations of X and Y. Find the average and standard deviation of 3 times X, of X plus Y, X minus Y, 4X minus Y. Different combinations of those random variables using the notes on the other board. So let's try the mean and standard deviation of 3X first. The expected or average value of 3 times random variable X would be 3 times the expected value of X, which is 3 times 80, or 240. 80 plus 80 plus 80, or 240. Let's do the standard deviation by first thinking about what the variance is. Remember, when combining random variables, it's the variance that combines, not the standard deviation. So the variance of 3 times X, if I'm given the standard deviation of X to be 12, the variance of X would be 12 squared, or 144. So this would be 3 times 12 squared. Of course, we want the standard deviation, but the standard deviation is just square roots of variance. So the standard deviation of 3X would be the square root of 3 times 12 squared. Square root and square cancel out, and 3 times 12 is 36. The average value of 3 times X would be 240. The standard deviation of 3 times random variable X is 36. Okay, now let's work with the combination of x plus y. What is the average value of the combination of two random variables, x and y? The average value or expected value of x plus y is the expected value of x plus the expected value of y. That's 80 plus 12, which is 92. The standard deviation is found by combining the variances. The variance of x plus y would be the square of the standard deviations we were given for those two random variables here. So 12 squared and 3 squared. Once again, remember, I can't say this enough. This is where people get mixed up. It's not 12 plus 3. It's the variances that combine, not the standard deviations. It's not 12 plus 3. It's 12 squared plus 3 squared. Of course, if I want to find the standard deviation of x plus y, standard deviation is the square root of the variance. So square root of 12 squared plus 3 squared, that's 144 plus 9. Square root of 153, which is about 12.37. All right, a couple of other different combinations. What is the expected value and standard deviation of x minus y? And what is the same for the next combination of 4x minus y? The expected value of x minus y is the expected value of the first minus the expected value of the second. So for the expected value of x, we have 80. For y, it's 12. 80 minus 12, or 68. The variance of x minus y is actually just the same number we got down here. Whether it's the sum or difference, by combining two random variables, I'm still increasing the total variability. I'm adding more variance in, whether I'm taking the combination of two random variables with adding or subtracting. So this is still the variance of x plus the variance of y. So we're going to have 12 squared plus 3 squared. In other words, the standard deviation of x minus y is the square root of 12 squared plus 3 squared. Standard deviation is the square roots of the variance. That's the square root of 153, or the same 12.37 from the previous example. Let's now do the last combination, 4x minus y. The expected value of 4x minus y is 4 times the expected value of x minus the expected value of y. That would be 4 times 80 minus 12. 4 times 80 is 320. 320 minus 12 is 308. The average value of 4 times random variable x minus random variable y is 308. The variance of 4x minus y would be 4 times the standard deviation of x, which is 12 squared, plus, almost caught myself. I'm doing the difference, even though it's the difference of our two random variables. By adding two random variables together, by combining two random variables together, we're increasing the total variability. So we're going to take this out. Plus 3 squared. So therefore, the standard deviation of 4x minus y is just the square root of this number. 4 times 12 squared plus 3 squared. It's 48 squared plus 3 squared. Take square root. It's 48.09. This is typically, once again, where people make their mistakes. Even though it's the difference of our two variances, I'm still increasing the total variability, so I have to add the two variances together. I'm doing 4 times the variance of x, so 4 times 12 quantity squared, plus the variance of y, so plus 3 squared. Standard deviation is the square root of the variance, so take the square root of that quantity for your final answer.